We're going to look at another special formula or special derivative, and it's the derivative of our natural exponential function, which is e to the x. The derivative of e to the x is probably the easiest derivative you'll ever learn. That being said, e to the x, the derivative of e to the x is just e to the x. If you wanted to look at y, remember derivative means slope, so if we looked at finding or calculating the slope of e to the x, it ends up just being a graph of e to the x once again. And one thing to keep in mind, though, that does make finding the derivative of our natural exponential function a little bit more difficult is the fact that we still have to use all of our rules, such as product rule, chain rule, quotient rule, things like that. So let's look at some examples of how those might work. So looking at example A, I have e to the 2x minus 1. So the first thing I notice is I have my exponential function, e to the x, but I also have this linear function inside of my exponential function. Since I have a function inside of another function, that prompts me to use my chain rule. So I'm going to go ahead and I'm going to say, using the chain rule, I'm going to let u equal 2x minus 1 and v equal e to the u. U prime would then be 2 and v prime would be e to the u. Therefore, the derivative of e to the 2x minus 1 would be u prime times v prime, which would be 2e to the u. But remember, I have to replace u back, so I end up with the derivative being 2e to the 2x minus 1. I know we talked in class about how sometimes you may need to write the chain rule out, other times you may not. You will probably get very good at calculating e to the u without using the chain rule, since it is a pretty basic formula. Notice that all I had to do was find the derivative of this inside piece here and multiply it by exactly what I already had. But that is going to be my derivative. Let's look at a second example, example B. Doing the same thing, again, I notice that I have this inside function. I have negative 3x up in my exponent, so I'm going to go ahead and use the chain rule again. I'm going to go ahead and say if u is negative 3 over x and v is e to the u, well, I could also say that that means that u is negative 3x to the negative 1, so u prime is just 3x to the negative 2. V prime is, of course, just e to the u. Therefore, my derivative of my given function is going to be u prime times v prime. So I get 3 over x squared times e, and I put u back in, negative 3 over x, and that will be my derivative. So notice that when I rewrote u prime times v prime, I did move the x to the negative 2 to the denominator, and also I did plug my u back in when I put my final function here. Looking at one more example, I have the derivative of x times e to the x. Since I have multiplication here, I am going to use my product rule. So I'm going to let f of x equal x, g of x equal e to the x, f prime of x equal 1, and g prime of x equals e to the x. Remember, my product rule tells me to take the derivative of the first times the second plus the derivative of the second times the first. So derivative of the first times the second is 1 times e to the x is just e to the x, plus derivative of the second times the first, e to the x times x. I am going to write the x first, and that would be my final answer using the product rule. So not overly difficult, just making sure to recognize when I have to bring my other rules in.